Good day, my students and viewers. I am Mr. John Paulo Eparibar, your science learning partner. Let us make our science classes be filled with saya. For today's session, we are going to tackle the Week 2 first quarter lesson. May I ask everybody to please open your modules entitled PS Shakingly Yours. For our today's lesson, we are going to talk about earthquakes and tectonic plates. And here are the learning objectives for this session. First, recall the characteristics of seismic waves in terms of speed. Second, explain triangulation method in locating epicenter of the earthquake. Third, locate the earthquake epicenter using triangulation method. And fourth, plot the active volcanoes, earthquake epicenters, and major mountain belts in a world map. To continue on with our session for today, let us have first a review. So let us prepare for a matching type test. So may I ask you to please get your pen and paper while answering this one. All you need to do is to match column A to column B. Column A consists of the words that we have learned from our previous lesson, whereas column B consists of their description or definition. Are you ready now? So let us begin. I will be giving you 1 minute to answer this test, and your timer starts now. Okay, time's up. So let us now answer our matching type test. So for number 1, the word is lithosphere, and the answer is letter D. It is the rigid outer layer of the earth consisting of the crust and upper mantle. Second word is plate boundary, and the answer is letter B. Plate boundaries are crack or gap between two plates. Third word is seismic wave. Seismic wave is letter A, energy released during an earthquake. For the fourth one, continental crust, and the answer is letter E. Continental crust is thicker and less dense type of crust. And for fifth word, we have oceanic crust, and the answer is letter C. It is the sea floor. So before we start with our lesson proper, let us watch this simple news update.
Niyanig po ng magnitude 5.6 na lindol ng Occidental Mindoro na naramdaman hanggang dito sa Metro Manila pasado alas 2 ng madaling araw kanina. Kaugnay niyan, makakapanamin natin si DOST Undersecretary at PBOX Officer in Charge, Renato Solidum. Magandang umaga po, Yusek Solidum.
Magandang umaga, Igan, at sa lahat po ng inyong taga-subaybay.
Ano na po ang latest sa naging pagyanig po dyan sa Occidental Mindoro?
Opo, ito yung pinaka-latest update natin. Ang magnitude na ay 5.6. Malalim ito, no? 121 kilometers. Kaya pagdating doon sa pagyanig na naramdaman, hindi gano'ng kataas. Ang intensity na pinakamataas ay intensity 4. Diyan sa Lubang, Mamburao, Paluan, at Sablayan, Occidental Mindoro, ganun din sa Puerto Galera, Oriental Mindoro, at Tagaytay City. Intensity 3 naman sa San Jose Occidental Mindoro at Rojas Oriental Mindoro. At dito sa Kamaynilaan, tulad ng Makati City, Quezon City, Mandaluyong, Malabon, Muntinlupa at Pasig, na i-report din na intensity 2. Yung ibang mga instrumento natin na nakakasukat ng intensity ay nakaramdam din hanggang Guagua, Pampanga, Tumaca at Mauban, Quezon, at Marilao, Bulacan, Talisay, Batangas naman ng intensity 1.
Opo. May mga na-record na rin po bang aftershocks, Yusek?
Wala pang significant na aftershock tayo nare-record. Although itong lindol na to ay sanhi ng pagkilos ng tinatawag na Manila Trends, no? At sa ibang bahagi, tulad sa bandang Batangas, may malalim din na lindol doon, pero hindi mismo sa exactly na lugar, pero related din sa Manila Trends.
May kaugnayan ba to sa mga nagdaang malakas na lindol din po sa Visayas at Mindanao? Magkakaugnay po ba yan?
Walang kaugnayan ng mga lindol kanina doon sa Visayas at Mindanao. Maghiwalay po na earthquake generator o ang kumilos.
So wala hong matinding banta po ito, Yusek, yung pagyanig na yan?
Yung pagyanig kanina walang epekto at wala rin tsunaming pwedeng maidulot. Pero Igan, bilang reminder, itong trends ay sa mga earthquake generator na ating kinonsidera parang makapaghanda tayo kasi ang senaryo dito kung mahigit magnitude 8 ang lindol dito sa Manila Trends, malakas na pagyanig ang mararamdaman ng mga probinsya sa harap nito at posibleng magka-tsunami. So parang gamitin na natin itong reminder na paminsan-minsan may malakas na lindol na tatama at kailangan natin talagang paghandaan ang lindol, pag-uga at mga panganib tulad ng tsunami.
Apektado ho ba ng COVID-19 pandemic yung mga ginagawa nating earthquake drill, lalo na sa social distancing, Yusek?
Yung pagkakaroon ng earthquake drill at tsunami drill ay apektado kasi hindi na masyadong nagagawa. Pero nagkaroon tayo ng abiso kung anong gagawin kapag lumindol. At kapag mag-evacuate na, ay dapat may distancing lalong-lalo na doon sa open area.
So now, based on the video that you have watched, what is the news all about? Correct! The news is all about the recent earthquake that happened in the Occidental Mindoro last October 5. So you have seen that our earthquake doesn't only reside in a single area or location. The energy of the earthquake can cause to radiate or can go to different locations based on its strength. So let us now start with our discussion. Let us review what are seismic waves. Seismic waves are energy released by earthquakes that travels all throughout the earth, just like what we have on our video a while ago. So from our earthquake that comes from Occidental Mindoro, the earthquake's energy are also felt in other areas of our country. From our grade 8 science, you have studied about the anatomy of the earthquake. We all know that the earthquake started on its origin, and we call that origin as the focus. Focus is the location where the earthquake started, and the area just above the focus is called as the epicenter. As you can see, the energy that comes from the focus also is being depicted just like ripples of water. They radiate outwardly. So for concept number 1, we will study about the different types of seismic waves. We have many types of seismic waves. The first two major classifications are the following. First, we have the body waves, and the second, we have the surface waves. Under body waves, we have P waves and S waves. In the surface waves, we have lobe waves and Rayleigh waves. So let us now begin. Body waves are seismic waves that travels within the earth. It comes into two forms. We have the primary waves or the P waves and secondary waves or the S waves. take a look at this illustration. This is how the energy from these two types of waves are acting. P waves, as you can see, acted just like sound waves. They are compressional in nature. Whereas S waves are shearing, or just like what we have on the shape of our curtains. The waves are moving in perpendicular motion just like a slinky coil. Surface waves are seismic waves that travels in the surface of the earth. It comes into two forms. We have the lob waves, or the horizontal shearing of the ground, and Rayleigh waves, or ground roll and travels as ripples. Here are the illustration. You can see in our lob waves, they are just like S waves, but in a form of sideward movement. So they are just like S waves in a horizontal position. Whereas Rayleigh wave are also just like S wave, but in a sense, the movement is vertical and can cause circular direction or shaking of the ground. So let us now have a review or recall for our concept number 1. So we have two major types of seismic waves. The first one is body waves. These waves travels within the earth, whereas surface waves travels in the surface of the earth. Our body waves has two types. We have P waves and S waves, whereas surface waves can be classified into lob waves or Rayleigh waves. So which one travels faster, P waves or S waves? So I want you to take a look at this video for you to be able to understand it better.
Effects. Now we'll be moving on to primary and secondary waves. You may be getting confused between the same primary and secondary in both names, so we call them S and P waves. So these S and P waves are very, very similar. In fact, they can travel through the Earth at fast speeds. But the differences are the P waves can travel through everything, but the S waves cannot pass through molten areas. These two types of waves are known as body waves, but there are also a third kind, surface waves. These can travel through the Earth's crust and don't travel within the mantle or core. I know the Earth is itching to have his say on this topic, so over to you, Earth.
Hello everyone. P and S waves have yet another name. P waves are also known as compression waves, and S waves can also be called shear waves. Why is this useful? Well, I always knew I was running inside, and humans knew about volcanoes, but no way of knowing how much of me was liquid. Have you ever wondered how humans discovered that my inner core was solid? Well, it is all thanks to earthquakes, and measuring the time it takes for the vibrations to pass through and around me. With clever maths, humans can work all this out. Now, on to one fact that you may not know. What is the difference between lava and magma? Actually, not a lot. It is all down to location, location, location. Molten rock within me is called magma. As soon as it runs over my surface, it is called lava. Back to you, Jordan.
Thanks, Earth. Now, I think I have had enough of this talk, so I will end the episode here. Hopefully you've enjoyed. Remember to subscribe.
Okay, let us now continue. So take note of the following things that you have learned from our video. First, P waves travel faster than S wave. Second, P waves can travel faster because it can travel to solid and liquid medium, whereas S waves can only travel in solid medium. The difference of the arrival time of P waves and S waves can determine the epicenter of the earthquake. and we can call it as lag time. So let us have the definition of Earth's or earthquake's epicenter. Epicenter is the area just above the focus of an earthquake. So for concept number 2, we will discuss about locating earthquake's epicenter by triangulation method. Based from kqed.org, scientists use triangulation to find the epicenter of an earthquake. When seismic data is collected from at least 3 different locations, it can be used to determine the epicenter by where it intersects. Every earthquake is recorded on numerous seismographs located in different directions or locations in our planet. So here is a video for you to be able to understand how to perform the triangulation method. So sit back and relax and watch the video carefully.
Hello everyone! In this video, we are going to learn how to locate the epicenter of an earthquake using triangulation method. During the movement of plates, seismic energy is released, resulting to an earthquake. The seismic data are then collected by stations which are used to determine the origin of the earthquake. This method requires data from at least 3 seismic stations. Let's take Philippines as an example. Zooming in this part of the map, we can find Phibox Lucban Seismic Station, Phibox Puerto Galera Seismic Station, and Phibox Ginayangan Seismic Station. The data from these stations will tell us their distance from the epicenter. This is done through identifying the difference in the arrival time of P wave and S wave as recorded in their seismograph. Remember that the arrival time of P wave and S wave will tell us how far the station is from the source. Since P wave travel faster than S wave, high value between these two tells that the station is far from the source. On the contrary, smaller value means it is closer from the epicenter. Take a look at the hypothetical data in the table. Let us assume that the following data were already derived from the actual difference in the arrival time of P wave and S wave. Let's begin with Phibox Puerto Galera Seismic Station. According to the data, Phibox Puerto Galera Seismic Station is 98 kilometers away from the epicenter. However, since the seismic wave travels in all directions, we cannot assume that the epicenter goes only this way, this way, this way, or this way. So, what we're going to do is to draw a circle with a radius of 98 kilometers. This will now give us a hint that the epicenter can be found somewhere in that circle. Moving on to Phibox Lucban Seismic Station, which is 81 kilometers from the epicenter. Again, since we are not certain of its direction, we are going to draw a circle with 81 kilometer radius. Notice that the two circles intersect at 2 points. This will now give us the idea that the epicenter may be found at this point or this point. This is where the third seismic station is needed. Now, let's take a look at the Phibox Ginayangan Seismic Station, which is 209 kilometers away from the epicenter. Following the same procedure, we are going to draw a circle with the 209 kilometer radius. If done correctly, you will notice that the 3 circles intersect at 1 point. This is the location of the epicenter. Thus, the epicenter is found at Tagaytay City.
So that ends our video. So for concept number 2, Locating earthquake's epicenter by triangulation. The epicenter of an earthquake is located by obtaining the distances of the earthquake from 3 seismic stations and searching on the point where they meet. This is called as the triangulation method. Okay, let us now continue for concept number 3, or the distribution of geologic features on Earth such as earthquakes epicenters, volcanoes, and mountain ranges. I want you to observe these 3 maps that we have from our last meeting. First, we have the map of earthquakes epicenter. Second, map of active volcanoes. And third, the map of mountain ranges. Take note of this observation, and we have said last meeting or last session that our 3 maps has been the evidences used by scientists to locate the tectonic plates or the major plates on our planet. The illustration above shows that most earthquakes happens on areas with active volcanoes. In the Pacific region, you have studied from your grade 8 science that the region is filled up with a lots of active volcanoes and active faults, and we call that area as the Pacific Ring of Fire. You can see that earthquake also happens in mountain ranges and ocean ridges. The illustration at the right shows the earthquake's epicenters. You can see the picture on the left as the maps of the mountain ranges. You can see some areas of earthquake epicenters found in the oceans, and those areas in the oceans are ocean ridges. For you to be able to know more about mountain ranges and ocean ridges, I have here 2 pictures. Mountain ranges are series of mountains that are found in plate boundaries. An example of it is the Himalayas. Whereas the ocean ridges, for which some of the earthquakes can also come, are series of underwater mountains, and example of it is the Marianas Trench. So for concept number 3, distribution of geologic features on Earth. The location of different geologic features such as earthquake epicenters, mountain ranges including deep ocean ridges, and active volcanoes almost lies on similar locations, and these locations are where most plate boundaries are found. And that ends our discussion for today. So for this moment, you need to remember all of these 3 important things, and it is found in a letter. Dear students, here are the 3 important things you must remember. First, seismic waves can be classified as body waves, which includes P and S waves, and surface waves, which includes Love and Rayleigh waves. P waves are faster than S waves. The difference of arrival time of P waves and S waves is used to determine the earthquake's epicenter from a seismic station. Second, earthquake epicenters can be located using triangulation method, where 3 seismic stations are needed. And third, earthquakes epicenters, active volcanoes, and mountain ranges are mostly distributed in same areas. These areas are boundaries of tectonic plates. P.S. Shakingly yours. So let us now apply what we have learned from today's lessons in our daily lives. We all know that we are all proud of our country, the Philippines. So let us now take note of these following things that we have in our country. So we all know that our country also has many active volcanoes such as Mayon Volcano, Mount Pinatubo, and Taal Volcano. Also in our country, there are many mountain ranges. An example of it is the Sierra Madre mountain ranges. And it is very not new to us that earthquakes are normal here in the Philippines. That is the reason why we are one of the earthquake zones in the world. And as we all know, based on our lessons, that these three geologic features are very normal or very ordinary in our country because we have, or our country lies on a plate boundary. So let us be aware of the things that we have been seeing or reading in our social media. The Department of Science and Technology, PVOX, or Philippine Institute of Volcanology and Seismology, has been given this reminder or warning to everyone. As we all know, because of the different series of earthquakes that happens in our country on the past weeks, there are many fake news that circulates in our country. Just like a technology says that there is a technology that can sense whether an earthquake will happen in a certain location or not. And here says the reminder. Paalala, ang DOST PVOX ay hindi nagbibigay ng prediksyon patungkol sa lindol o tsunami. Pakiusap, huwag maniwala o mag-forward ng anumang impormasyon na maaaring lalong makadagdag sa pagkalito at pagkatakot ng mga makakabasa nito. So, as citizens of our country, we should be all responsible for all of the information that we circulate in our social media account. So, to get updated and be aware of the important information regarding volcanic eruptions and earthquakes that happens in our country, you can follow the DOST PVOX page, which is present in our Facebook. So come on, before we end our lesson, let us check your understanding. So for today, we will be having a multiple choice test. You need to choose the letter of the best answer. In every question, you will be given 10 seconds to answer each. Are you ready to begin? So let's get started. First question. What is needed to determine the distance of the epicenter from a seismic station? I repeat, from a seismic station. Letter A, the arrival time of P wave and S wave. Letter B, the difference in the arrival time of P wave and S wave. Letter C, the arrival time of P wave and S wave from three different seismic stations. Letter D, the difference in the arrival time of P wave and S wave from three different seismic stations. So let the timer starts now. The correct answer is letter B, the difference in the arrival time of P wave and S wave. Second question. What point on the surface of the Earth lies directly above the origin or focus of the earthquake? Letter A, epicenter. Letter B, focus. Letter C, mountain belt. Letter D, volcano. And your timer starts now. The correct answer is letter A, epicenter. Let us now move on to the third one. What do you call the series of mountains that lie along the same plate boundary? Letter A, epicenter. Letter B, focus. Letter C, mountain belt. Letter D, volcanic arc. And timer starts now. And the correct answer is letter C, mountain belt. Next question. What type of body wave cannot travel through the liquid layer of the Earth? Letter A, P wave. Letter B, seismic wave. Letter C, surface wave. Letter D, S wave. Your timer starts now. The correct answer is letter D, S wave. S wave cannot travel through the liquid layer of the Earth. That is the reason why they are also the slower than the P wave. Next question. What is needed to determine the epicenter of an earthquake? Letter A, the arrival time of P wave and S wave. Letter B, the distance of the epicenter from a seismic station. Letter C, the difference in the arrival time of P wave and S wave. Or letter D, the distance of the epicenter from 3 seismic stations. And your timer starts now. And the correct answer is letter D, the distance of the epicenter from 3 seismic stations. And we call that method as the triangulation method. So congratulations! We have now ended our session for this morning. But before that, let us check whether what you are going to do with your scores from our test. So if you have 4 to 5 points, you can go on to the next lesson. If you have 2 to 3 points, you should review your misconceptions or your wrong answers from the test. And if you have 0 to 2 points, you should watch again this video. So thank you for watching this video lesson for our week 2 first quarter lesson. You can subscribe to me to my YouTube channel, John Paulo Baribar, or you can reach me in my FB name profile, Baribar John Paulo. So here are my references from this video. Thank you very much for watching. Bye-bye!